Okay, let's finish section 1.4. For the next several problems, I want to draw what I call my butterfly picture. So we're interested in whether trig functions are positive or negative in a certain quadrant. So for example, in the first quadrant, if I had an angle, whose terminal side stopped in the first quadrant, my triangle picture would look like this, wouldn't it? So, there's the terminal side, and I would draw my triangle with a vertical line. What would the triangle look like in the second quadrant? So if theta rotated to the second quadrant, my terminal side would look like this, and I would draw my triangle with a vertical line. In the third quadrant, it would look like this. In the fourth quadrant, it would look like this. Okay? So this is what your triangle pictures look like in each of the four quadrants. Now, let's start with the first quadrant. So this point right here, if that's the point xy, is x positive or negative in the first quadrant, and is y positive or negative in the first quadrant? Well, in the first quadrant, x is from here to here, that's a positive number, and y is from here to here, that's a positive number, and we learned r is always positive. So I'm just labeling my triangle here with whether x and y and r are positive or negative. Now what about in the second quadrant? In the second quadrant, here's my point xy. X, you go from here to here, x is negative. Y goes from here to here, y is positive, and again, r is always positive. So in the second quadrant, x is negative and y is positive. Again, how am I figuring? I'm thinking about this point right here. Right? If this is the point xy, are x and y positive or negative? X is positive, y is positive. In the second quadrant, x is negative, y is positive. Now what about in the third quadrant? In the third quadrant, to get to this point, you would do this, that's x. Again, x is negative, and going here, y is negative. R is always positive. In the fourth quadrant, for this point, what would it be? X is positive, y is negative. And again, r is positive. You don't really have to put the r in there, because r is always positive. So if you think about this picture here, and you want to know whether a function is positive, a trig function is positive or negative in each of the quadrants, just think about this picture. And again, you don't have to draw it, you can think about it in your head. For example, in the first quadrant, suppose I have an angle that stops in the terminal side in the first quadrant. Sine is y over r, plus over plus. Cosine is x over r, plus over plus. Notice in the first quadrant, if you pick any trig function, sine, cosine, tangent, cosecant, secant, cotangent, you're going to take a positive divided by a positive, aren't you? So in the first quadrant, every trig function is going to be positive. So you don't even have to really think about the first quadrant. Every trig function, all 6 of the trig functions are positive in the first quadrant, because you're always taking a positive divided by positive. What about, say, in the fourth quadrant? Okay. So, for example, suppose I was interested in sine theta in the fourth quadrant. Well, in the fourth quadrant, sine is y over r. Right, or opposite over hypotenuse. Again, when I say opposite and adjacent, I'm referring to the angle in the triangle near the origin here. So opposite over hypotenuse. So sine is going to be negative in the fourth quadrant, isn't it? Less than 0. Right? And cosine is plus over plus. Cosine is positive. So if you just think about this picture, you can figure out whether trig functions are positive or negative. Okay? Or, now a fact that will help you. Every trig function is positive in 2 quadrants and negative in 2 quadrants. Now, depending on the trig function, there may be different quadrants, but every trig function is positive in 2 quadrants. Every trig function is negative in 2 quadrants. So, for example, let's go ahead and do an example here. So it says identify the quadrant or possible quadrants, it could be more than one answer, of an angle theta that satisfies the following. Sine of theta is positive, and simultaneously, we want cosine theta to be less than 0, negative. Okay? So from what I just said, I know where is sine positive? 2 different quadrants. Where is cosine negative? Two different quadrants. So let's figure out each of these problems separately. So where is sine positive? You could just think about this picture and run through each of the quadrants if you wanted to. So for example, in the first quadrant, you know sine is positive. Right, there's nothing to do there. Every trig function is positive in first. Now, what about second quadrant? Sine is y over r, or opposite over hypotenuse. So it's positive over positive. Sine is positive in 1 and 2. I don't even need to check the other 2 quadrants, because I just told you sine is positive in exactly 2 quadrants. But let's just check anyway. In the third quadrant, sine is negative. Fourth quadrant, sine is negative. So it doesn't hurt to go ahead and double check, because if you made a mistake here, you'll catch yourself you know, if you go through all of them. Now, another way to think about this, if you without going through all the quadrant, think of it this way. If I want sine theta to be positive, remember sine is y over r. If I want this fraction to be positive, what has to be true? Either both of these numbers are positive, or both of these numbers are negative. That's the only way to get a positive answer when you divide it. Either both are positive or both are negative. R is never negative. So the only way for y over r to be positive is if y is positive. And where's y positive? Y is positive above the x-axis, which is first and second quadrant. So you can kind of think your way through it too. All right, let's do cosine less than 0. Okay. Well, let me just use the argument I just used. So if I want cosine, remember cosine is x over r. Suppose I want that to be negative. I want x over r to be less than 0. X over r is negative. Okay. What's the only way for a fraction to be negative? One of the values is positive and one of the values is negative. But r is always positive. So the only way x over r could be negative is if x is negative. And where is x negative? X is negative to the left of the x-axis. Notice you're in the second, third quadrants. Okay. Now, that's one way to argue, or you can just do where's cosine negative. First, it's not the first quadrant because every trig function is positive in the first. So cosine is x over r, that's negative. Cosine's x over r, that's negative. Cosine's x over r, that's positive, so it's second, third. So however you want to do it, right? But you can do it, if you just think of this picture, you can do it in your head. So let's answer the question now. Sine is positive in these two quadrants. Cosine is negative in these two quadrants. So in which quadrant does theta have to be? To satisfy both equations simultaneously, theta would have to be in the second quadrant. It has to satisfy both. Right? In the first quadrant, cosine's not negative, so it can't be first. It's what they have in common. Okay, so that's that one. The next one says, identify the quadrant or possible quadrants of an angle theta that satisfy the condition tangent of theta is greater than 0. So tangent's positive. Now, without even doing anything, how many answers are there going to be to this question? There has to be two quadrants, right? Every trig function is positive in two quadrants and negative in two quadrants. We only got one answer here because there's two conditions to satisfy. So, but there's only tan theta positive. I know there's two answers here, and I know one of them is first, don't you? Every trig function is positive in the first quadrant, so I know that's an answer. So you could, run through the picture, or you could do what I did a second ago. Tan of theta, remember tan is y over x. If I want that quotient to be positive, x and y are both positive, or x and y are both negative. If x and y are both positive, notice you're in the first quadrant. Where are x and y both negative? Third quadrant. Or you could just run through the quadrant. Right? Tan is opposite over adjacent, or y over x. Positive, negative, positive, negative. So first and third. So where is tangent negative? Tangent's negative in second, fourth. The other two. Okay. The next question says, give the signs, S-I-G and S, so positive or negative, for sine, cosine, and tangent for the angle 298 degrees. So I'm interested in sine of 298, cosine of 298, tangent of 298. Now, it doesn't say find the value of it. It doesn't say put the number value. Let me get rid of the equals. We just want to know whether this answer, the value for each of these is positive or negative. And it really has nothing to do with the 298 specifically. What's important is in which quadrant is 298 degrees. Once you know the quadrant, you can just use your little butterfly picture. Now, where's 298? Well, it's not all the way around, because that would be 360. Halfway around is 180, so it's more than halfway around. Now, where was this angle here? It's 90 and 90 and 90. That's 270 degrees. So we need to go past 270. So 298 is in the fourth quadrant. Okay? So 298 degrees is in quadrant 4. And so in quadrant 4 is sine positive or negative. Sine is opposite over hypotenuse. That's negative. Don't put negative out there. I know I did that in that picture, but we have a symbol for that, less than 0. And cosine of 298, cosine's x over r, positive over positive, so that's positive. And tangent in the fourth quadrant is opposite over adjacent, so that's negative. Okay, So that's I don't know what the numbers are, but I know sine is negative, cosine is positive, tangent is negative. Right? So once you figure out what quadrant's in. What if I change the problem to 200? What if I change the problem to 280 degrees? How would that change the solution? Well, where's 280 degrees? 280 degrees is also in the fourth quadrant, so the solution wouldn't change at all. Right? Any angle in the fourth quadrant would have these same answers. Okay, so the next problem says, decide whether this statement is possible or impossible. So that secant, that's the Greek letter omega, plus 1 is 1.3. So determine whether this is possible. So is there an angle where secant of the angle plus 1 is 1.3? Well, even if you didn't have a clue where to begin, there's something probably leaping off the board at you to do first. And that's, subtract 1 from both sides. Secant omega is 0.3. I mean, even if you didn't know where to go, you would probably want to do that first anyway. Okay? So I have secant of omega equals 0.3. That looks more like a W than omega. Okay. So can secant omega be 0.3? Now, what concept is this problem testing? Right? This is testing the ranges of the trig function. Okay? Can secant of an angle equal 0.3? Well, remember, from my little diagram I did before, right? Sine and cosine were trapped between plus or minus 1. Secant and cosecant theta were outside plus or minus 1. And again, I didn't put tan or cotan because they can be anything. Notice where's 0.3? 0.3 is between plus or minus 1. Sine and cosine can equal 0.3. Tan and cotan can equal 0.3 because they can be anything. But secant and cosecant are 1 and bigger and minus 1 and smaller. Secant cannot be 0.3. This is impossible. Okay, so I'm using the ranges of the trig function to figure out that problem. Now these last three problems have the same flavor. Remember I mentioned there are 4 different types of problems where they give you information, certain information, and then they say find trig function values. Sine, cosine, tangent, etc. Okay? So this is the 4th type. Can you remember the first 3 types that we've done already? The first type was, here's a point on the terminal side of angle theta. Find the trig function values. Here's the point. The second type was, the terminal side of angle theta lies on a line with a certain restriction. Find the trig function value. So for that, remember, we use the information to find a point, and then we were back to the first case. The third case was, here's an angle, 90 degrees. Find the 6 trig function values. And now this is the 4th type. The 4th type is they give you one of the trig function values, and then they say find others. Okay? So this one says, suppose cosine of theta is 1/3, and suppose theta is in the 4th quadrant. And it doesn't say find all the others, it says find tan of theta. But notice in the notes I say, note the book uses identities for problems like these. I think using pictures is easier. So be aware, if you look at examples like this in the book, they're going to use like Pythagorean identities to figure it out. I think it's easier just to draw a picture, so I'm going to do it that way. Plus, if you have the picture, right, the triangle picture, you can do all 6 trig function values. If you do it the way they're doing it, you use an identity to find the one they're looking for. So I'm just going to draw the pictures we've been drawing. So cosine theta is the 3rd and theta is in the 4th quadrant, right? With this information, let's draw a picture of angle theta. Theta's in the 4th quadrant. I don't know the rotation, I'm just going to put something in. Right? There's my angle theta. I drew my terminal sides here. I finished my triangle with a vertical line. Don't do it with a horizontal line. Okay? Now, notice they told me cosine is a 3rd. They gave me one of the trig function values. Before, they didn't give us these. Well, cosine, what's cosine? Cosine is x over r. So if we let x be 1 and r be 3, this picture would satisfy cosine theta is a 3rd. So if I put a 1 here and a 3 here, notice cosine would be x over r. It would be a 3rd. Okay? Remember, you can choose any point you want on the terminal side of angle theta, so I'm choosing the point where x is 1 and r turns out to be 3. Notice here I'm missing y. In the previous problems we did when they gave us a point, we knew x and y and we didn't know r. So here we know x and r and we don't know y. So we need to figure out what y is. We'll just use Pythagorean theorem. 1 squared plus y squared is 3 squared. Now be careful, the r, right, it's length of leg squared plus length of leg squared is length of hypotenuse squared. So be careful, the order matters here. Make sure the 3 is over here by itself. So I have 1 plus y squared is 9. So y squared is 8. That's pretty simple. Okay, so we need to take the square root of y. So y, now when you introduce a square root, there's no square root in the problem. When you introduce an even root, 4th root, 6th root, and square root, you have to take the plus or the minus. So this is really, we have to have a choice here. It's plus or minus the square root of 8. I'm fine if you leave it square root of 8. If you want to simplify, that's 2 root 2, isn't it? Because 8 is 4 times 2, square root of 4 is this 2. Right? Now you have to be careful here. In this picture, here's y. In the 4th quadrant, y is negative. So y here is minus 2 root 2. So it's not the plus, it's actually the minus. Right? So an extra step you have to add into your little procedure is check to see if any of the values on your triangle are positive or whether they need to be positive or negative. We didn't have to check that before because they gave us x and y, and we figured out r, which was always positive, so we didn't have to make a choice. So be careful. If you're outside the 1st quadrant, when you draw your triangle pictures, you need to, at the very end, ask yourself, do any of the values need to be plus or minus? So add that into your checklist. Again, if you left that minus root 8, I'm fine with that. Be aware that answers in the back of the book are always going to simplify radicals. Just be aware of that. Okay, see, I have all 3 values now, x, y, and r. I could do the other 5 trig function values. I have my picture, so that's why I don't like using those identities. I think that they do that in the book to make you practice with identities, but for a problem like this, I think it's a waste of time. So just look at your picture. What's tangent going to be? Tangent is y over r, or opposite over hypotenuse. So it's minus 2 root 2 over 3. And again, I could do all right. What's the sign? Oops, I did that wrong. That's sine. Sorry. Over 1. Okay, so sine is minus 2 root 2 over 3. Tangent's minus 2 root 2 over 1. Cotangent's 1 over minus 2 root 2, etc. So once you have the pictures, you could do all 6 trig function values, so not just 1. Typically on a test, I ask for 2 or 3. If you're going to do all the work to do the picture, I usually have you do 2 or 3. I rarely have you do all 6, because once you get the picture, that you know what you're doing, you fill in 2 of them, that tells me you know what you're doing. Okay, so the next one is similar. They give you a piece of information, and then they want you to find trig function values. Okay, so the next one says, suppose tangent of alpha is 0.98244, and suppose cosine of alpha is less than 0. Okay, so they gave you information, and they want you to find cosecant alpha. Again, once you have the triangle picture, you could do all 6 trig functions. Okay, so let's draw a picture of angle alpha. So let's think about the steps here, right, when drawing your picture. I want to draw a picture of angle alpha. What's the first thing you need to figure out? Okay, notice in the last problem, they told me that the angle was in the 4th quadrant. They didn't tell me that here. We have to figure that out. That's why we went through all that butterfly picture stuff. Right? Tangent is positive. Where is tangent positive? We did this problem actually a little while ago. Tangent's positive in the 1st and the 3rd. But we need cosine to be negative. Where is cosine of alpha negative? Cosine is negative in the 2nd and the 3rd. So tan is positive in the 1st and the 3rd. Cosine is negative in the 2nd and the 3rd. So we have to be in the 3rd quadrant. So they didn't tell us that. We had to figure it out. Okay, that's why we went through that butterfly picture stuff. That is the only reason they gave you this fact. Because without this fact, tan is positive, you wouldn't know whether you're in the 1st or the 3rd. So this fact is just giving you to help you restrict it, figure out that in 1 and 3, it's really 3. Okay, so alpha's in the 3rd. That's an ugly triangle. Okay, that's a little better. Okay, so now what was the next step? Now we need to put our numbers on the side of the triangle. Now they only gave you one number, but just think of that as over 1. Okay, and the last example they gave us 1/3, so they gave us 2 numbers. If they ever just give you a single number, put it over 1. Now you've got 2 numbers. Okay, so now what's tangent? Tangent's opposite over adjacent, or y over x. So 0.98244 and 1. And now we need to figure out r. Well, we know how to do r. R is the square root of 1 squared plus 0.98244 squared. And again, I'm not going to do exact here. This is probably a rounded number, so I'm just going to punch this in the calculator and get a number. Now, before I punch it in, you know that this number is going to be bigger than 1. It's bigger than both of these numbers, right? So if you don't get an answer bigger than 1, you know you've made a mistake. And so if I do 1 squared, that's 1. 1 plus 0.98244 squared is about 1.965, but I have to take the square root of that. I get about 1 point, I'll go to 5 places because that's what they have. 40185. 40185. Okay, in this book, they're doing a lot with significant digits. I'm not worried about significant digits. So, I mean, on a quiz or test, I will typically tell you round to 2 places, round to 3 places. If they don't tell you, notice here they gave me 5 decimals, so I went to 5 decimals. Don't worry about significant digits, but just be aware in the back of the book, if you round a couple places, they may go do significant digits and their answer may be a little bit different than yours. Okay, so the hypotenuse here is 1.40185. Well, so what's cosecant? What's the definition of cosecant? Cosecant is r over y, or hypotenuse over opposite, 1.401, 1.40185 over 0.98244. Okay, let's see what we get. 1.40185 divided by 0.98244. And I got about 1.42691 if I go to 5 places. 1.42691. Okay, how do we feel about that answer? Remember, cosecant has to be bigger than or equal to 1 or less than or equal to minus 1, so that makes sense. Is this the right answer? This is not the right answer. What's the problem here? Some of you may have already realized it when I was doing the problem. I purposely ignored it to see if you would catch it. I remember that extra step I said you need to check on before you get to the final answer. I never checked to see if any of these sides need to be negative. Okay, in the third quadrant, x and y are both negative. Right? Now r is positive, right? So how's that going to change? I'm going to have a negative here and a negative here, right? Right? In the third quadrant, cosecant is negative. So that should be another thing you could check. Right? In the third quadrant, cosecant should be negative. So, right? Don't forget to check whether any of your values need to be positive or negative, right? Don't forget, once you put all the numbers in. Now, why didn't we catch that here? Why didn't we catch that as we did the problem, right? Because notice the answer here was positive. You put it over 1. That's a positive over positive is the same as a negative divided by negative. So it didn't, you don't catch it from the numbers here, right? When we did, well, that one, we didn't catch it there either. And the next one you'll see. Don't forget to check for pluses and minuses. Okay, I consider that a major mistake if you don't have the positives and negatives in the right place. Okay, so that's that one. Again, once you have the picture, you could do all 6 trig functions. And the last problem is it has exact same flavor as these last 2. And the last problem says find all the trig function values for the angle gamma if cotan gamma is minus 3/4. See here, the negative is in the problem, so it makes you think of the positives and the negatives, whereas the last one didn't. And theta is in the second quadrant. All right, here they actually told you the quadrant. Okay, so pause the video and see if you can draw the picture of this angle with all 3 sides labeled. See if you can do that first. Okay, so let me do this. So theta's in the second, gamma's in the second quadrant. Again, I don't know that's a rotation. I just like to put something in. There's gamma. Now, what's cotangent? To be honest, I just ignore the negative sign, figure out where the 3 and the 4 go, then put the negative where it needs to go. Because the negative could be on the 3 or it could be on the 4. It's not on both, because you'd have negative over negative is positive. Okay, so in the second quadrant, there's a picture of what this angle could look like. And cotangent is the adjacent over the opposite. So I know 3 is here and 4 is here. Now look at your picture. You know where the negative goes. The negative is on the 3. because in the second quadrant, x is negative and y is positive. So be careful. I mean, if they had written this as 3 over negative 4, that doesn't mean the negative is on the 4. Okay? Think of it this way. The negative could be on the 3 or the 4. Okay. Now, you could use the formula for r to find r, but remember, we did this as a very first example a couple sections ago. When you have a right triangle with legs 3 and 4, the hypotenuse is 5. Remember, I told you you probably just want to memorize that one. But if you don't remember that, you could just use the formula for r. Well, now we can do all 6 trig functions. Sine of gamma, cosine of gamma, tan of gamma. If they give you one, you don't have to write it again. I'm not going to write cotan. Cosecant gamma, secant gamma, and cotan. Okay? Anything that they give you, you don't have to write it again. Well, let's look at the picture. What's sine? Sine is opposite over hypotenuse, or y over r. That's 4/5. So cosecant is 5/4. Cosine's adjacent over hypotenuse, or x over r. That's minus 3/5. So secant's minus 5/3. And tangent is opposite over adjacent, or y over x, which is minus 4/3, or you know it's a reciprocal of this one. Okay, now I really should have spaced my answers out better. All right, when you're doing your work, space out your work, please. All right, there's no point in bunching it all together. Okay, so that's that one. So notice these last 3 all have the same flavor. I followed the same steps. You should do the same thing.